Hello viewers, here we have our S35 304 stainless steel, normally closed differential solenoid valve. So the body here is 304 stainless steel. Now it's a differential valve, so what does that mean? Well, if you see this little arrow of flow on the side of here, it means there has to be a difference in pressure between the inlet and the outlet of the valve. So this particular model, which is a 1 inch, has a 0.3 bar differential. So where can't you use this valve? Now you can't use it in, say, tank drain, low head pressure applications, vacuum, anything where you don't get a differential pressure drop across the valve, you can't use it. So where's it's good? Well, it's good in applications such as mains water, downstream of a pump, compressed air lines. So this valve here, it's got an EPDM diaphragm, so it's good for water, compressed air, any sort of inert chemicals, or inert media I should say. Now, if we'd like to take this valve apart, I'll show you how it works. I've just got a 14mm spanner here, and I'll take the top of the coil off. So this is the coil. It's the part which obviously you hook the power up to if you want to install this valve. When power goes to it, it creates an electromagnetic force within here which lifts the armature up in the operator stem. So to take the body of the valve apart, I'm just going to loosen these 4 bolts off. So as we lift the top off this valve, you will see underneath is a spring. Now this spring sits in a little seat there in the top of the diaphragm, and it pushes against the underside of this valve. So you can see it needs a differential pressure because this spring is actually holding the diaphragm in place. Now the 0.3 of a bar in this case is actually to overcome this spring tension and push this up. The diaphragm itself, here you can see has 2 holes in it. Now it's got a hole in here, which is the bleed hole, that lets pressure onto the top of the diaphragm. And this little bit of the diaphragm here, which sits in the gallery, that's the bleed off, where it takes it from. You see this arrow of flow here, takes from upstream, there's the arrow, upstream. The liquid comes around, or air, goes on top of the diaphragm. Now it can't escape because this hole is blocked off. When you actuate the valve or put power to the valve, the armature lifts up and lets the water go off down the bleed hole. Now, if you're maintaining this valve, it's important to note that this little hole here in the diaphragm is clear. Both of these holes are clear. Also check this seat, the machine seat, to make sure this is clear. So here, this is where water goes, flow path down and out. We'll have a look at the operator of the valve. So here we can see the gallery. This is the bleed off gallery which goes down. Here it comes. In here's a hole that comes on. Here's the bleed off jet. Now this armature here sits on the little jet in there. Now that sits closed. When you put power to it, this is lifted up, lifts off that jet, and pressure can bleed off the top of the diaphragm. Now in the operator itself, we have an armature, a spring which sits in the top of the armature, and the operator tube. So to put this back together, the spring goes to the top, armature goes in, and this screws back in.